What's up everyone, Patrick here, welcome back, and in this video what we got to do is find the union and intersection of these sets over here. So we got question 1, set A. We have x as an element of real numbers, so all the real numbers that are greater than -1 but less than or equal to +3. And then set B is x squared plus 2, that's the formula for the elements in this set, where this x here such that x is an element of real numbers. So how can we do this here? Well, first off, I'm going to take these, if possible, and put them in interval notation. This one we can for sure put in interval notation. So we got -1 to +3. That's a square bracket right there. What about this one here? This one's a little bit trickier. We got x squared plus 2. Now notice that if we look at these separately, notice x squared, no matter what real number we plug in. Remember, real numbers, it's all the numbers from -infinity to +infinity. No matter what real number we plug in, x squared is always going to be greater than or equal to 0. Right? You can see it with the graph as well. X squared is just a parabola. Notice all the values are greater than or equal to 0. So any negative value, since we're going to square, it's going to turn positive. Then if we take 0 and square, it's just going to be 0. So if this term is going to be greater than or equal to 0, and then we're adding 2 onto that, then notice that this here is going to be greater than or equal to 2 all the time. Right? So we have this, it's like we add 2 to both sides. Another way, you could take x squared plus 2 and graph it. So if we take x squared plus 2 and graph it, notice x squared plus 2 is just x squared shifted up by 2 units. So it's going to be over here, right? And this is at, this vertex here is at 0 and 2. So notice that this is always going to be greater than or equal to 2, and it's going to go to +infinity. It's going to continue going up. So this set B, we can actually take it, if we were to write it in interval notation, it would be from 2, inclusive of the 2, to +infinity, like that. Right? So we took these two sets, put them in interval notation. Now, if we want to put them on a number line, just to visually show how this is working, notice that set A, it's going from -1 to 3. It's not inclusive of the -1, but it is inclusive of the +3, like that. And then this one, we're going from 2, so 2, it is inclusive of the 2, and then that's going on forever to +infinity. And so from here, it's easier to see what is the intersection and then the union. So let's start with the intersection. The intersection of these two, what's common? Here to here. Right? So from 2 to 3, all the real numbers between 2 and 3. So we could represent that, and inclusive of the 2 and 3 as well. Right? Because these are dots here. Right? They're common in both sets and all the numbers in between. Another way we can show this is we could say all the real numbers from 2 to 3. All right, that's what the intersection is. And then what's the union going to be? Well, it's going to be A or B. All the numbers or all the elements that are in A or B. So notice that's going to start from here. It's going to include these numbers that are in both of them, and then it's going to continue going. So it's actually the union set is from -1, not inclusive of the -1, to +infinity, like that. Or another way, if we wanted to write it, is XER, such that x is greater than -1, like that. Right? So both different formats here. All right, so we got the union for these two sets and then the intersection. Now moving on to number 2, we got the two sets A and B. So A is x is an element of real numbers such that x squared is greater than 100. And then set B is x is an element of real numbers such that x squared is less than or equal to 225. So we're dealing with real numbers. Let's see if we could potentially put these in interval notation, depending on what's given, the type of formula, and basically, yeah, what kind of set builder notation is given. Even if you're working with real numbers, it's not always guaranteed that you're going to be able to put it in interval notation, but let's see what we can do. So we got all the real numbers, but it can only be the real numbers where this condition is satisfied, right? Such that x squared is greater than 100. So when is x squared greater than 100? Well, if we graph x squared, which looks like this, when is it going to be greater than 100? Well, notice that the x values, when it equals 100, on x squared is going to be negative 10 and positive 10, right? Negative 10 squared is 100, positive 10 squared is 100. So it's going to be greater than 100 over here for these x values and then over here. So it's basically going to be all the x values that are greater than 10 and less than negative 10. Right? Not inclusive of them because it has to be greater than 100, not greater than or equal to 100. So that's one way to do it. What I personally do, whenever I get something like this, I actually bring everything to one side. So you could show it like this, but it's not always going to be a nice graph like x squared. And so sometimes you're going to have to bring everything over and then do some factoring potentially, or maybe use even the quadratic formula to find those intercepts. So if we have x squared is greater than 100, we would bring it over, x squared minus 100. When is that going to be greater than 0? Well, if we factor this, we can take this quadratic now and graph it. We got intercepts at negative 10 and then positive 10. And it looks like that. So when is it greater than 0? When is it above that x-intercept, or x-axis rather, over here and over here as well? So notice we're still getting the same answer when x is less than negative 10, when x is greater than positive 10. But it's just a different way to work with this inequality. And I suggest doing this method because, again, it's not always going to be like an x squared. Let's say this was like, I don't know, let's say x squared plus 5x is greater than 100. Then doing it that first way is going to be a lot tougher, right? You'd have to bring this over, find the intercepts, and I don't even think this would factor smoothly with the positive 5 and the negative 100, so you'd have to put in the quadratic formula to find these intercepts here, right? So this is the method that I would recommend personally. So this here, this set, if we were to take it and write it in interval notation, it would be from negative infinity to negative 10, or from positive 10 to positive infinity, like that. All right. Now, this set B here, I'm going to use the exact same method, but I'm going to bring the 225 over, and then when is that going to be less than or equal to 0? Notice this is a less than or equal to sign. So if we factor this, it's a difference of squares. So we'll have negative 15, positive 15. Notice this is a parabola that opens up like that. So when is it less than or equal to 0? That's going to be in this area over here. And equal to 0 as well, we're going to include the intercepts. So this set, we can actually rewrite all the values between negative 15 and positive 15, all the real numbers between negative 15 and positive 15. Right, so this set we took, rewrote in interval notation. This set we took, rewrote it in interval notation. And so now I feel like it's easier to work with both of these sets and finding their union and intersection. So I'm actually going to take this and draw a number line. So let's say, how can we do this? Yeah, this is 0. Let's start with set B. So negative 15 over here to positive 15, inclusive of both of those. So it looks like that. And then this set here, it's from negative infinity to negative 10. This is not to scale here, but we got negative 10 is not inclusive of the negative 10, so that's an open dot. It's like that. And then we got positive 10. So there's an open dot over here, and it looks like that, right? So this here on the number line is set A, and then that is set B. And then from here, I feel like it's easier to get the union and intersections, or the intersection. There's actually going to be two areas, though, where they intersect. So the intersection between them, well, notice it's going to be, it's basically where do the lines overlap? Well, in this area over here, and then in this area over here. So it's from negative 15, inclusive, because it's in both, to negative 10, even though it's in this set, negative 10, it's not in this set. It's not in set A. So we wouldn't include the negative 10, so the negative 10 would be a circle bracket. It's got to be in both in order for it to be in the intersection set. So negative 10 is in this set, but it's not in this one. So it's just before negative 10. So that's one area, and then the other area we would put, or it could be from positive 10, circle bracket, to positive 15, inclusive of positive 15. It's in both sets like that. Right? So that's one way to show the intersection set. Another way, we could say any real number such that x is between negative 15, greater than or equal to negative 15, but less than negative 10. Or you could put or here, or you could put a comma. Positive 10, greater than or equal to, sorry, greater than positive 10. It's just greater than positive 10, less than or equal to positive 15. So any real numbers, but with these conditions, where this inequality holds, or, you know what, I'll just put or here, or that inequality holds. So that is the intersection. That's what elements are common in both. And then the union is actually pretty easy. Notice that it's going to just be from negative infinity to positive infinity, right? Because all the numbers are covered by at least one of the sets. Here it's covered by set A, then this area is covered with both, and this area is covered with set B, this area is with both, and then this is covered with set A. So the union, A or B, the union set would be from negative infinity to positive infinity, like that. If you wanted to put in this notation, actually you could just write x as an element of real numbers. There's no condition. You don't have to write such that. Right? It's just all the real numbers. All the real numbers are from negative infinity to positive infinity. So we got the intersection, two different formats for the set, and then we have the union set.